Hello, 108 class, Mr. McHugh back here with you, continuing our work on section 2.7 and our absolute inequalities, and of course we're going to tackle page 2 here. Now on this page, what I wanted to do was take the three cases for absolute value and use some examples out of the book. And in this case, instead of it just being very simply x inside the absolute value, you're going to have an algebraic expression, and we're basically going to work with 2x plus 1. We're going to do three cases: equal sign, greater than, and we'll do the less than one down here. Okay, so what you have to remember on these cases, when you hear absolute value, you got to remember that the expression inside the absolute value chamber, inside the two vertical bars, can either be a positive or it can be negative. And I like to set them up that way, and then all you're going to do is evaluate the first. In this case we had equal signs, but the first case, which is going to be inequality down here, first case, and then the second case, the positive case and the negative case. Okay, now usually the algebra is not too bad here. Now the positive, you do not have to distribute anything because a positive 1 inside here will not change it, so I dropped the parentheses. I got 2x plus 1. I minus 1 on both sides, divide by 2, and I got x equals 3. Okay, everybody should be pretty comfortable with that. The big thing you got to remember is the second case I call the negative case. You got to distribute a negative 1 and multiply it. Oh, excuse me, I'm sorry, across the parentheses. Negative 2x minus 1 equals 7. Add 1 to both sides, divide by a negative 2, and you get x equals negative 4. Find your two values, x equals 3, x equals negative 4, and if you put both of those values into the expression back in the original problem, you will find out they will equal 7. Okay, so that's the first case. We're not going to do too many of these with equals. It's going to be the inequalities is the focus of this section. So let's go ahead and look at objective 3 here a little bit. And now let's go ahead and take the same problem, and this time it's the greater than. Okay, remember, you've got absolute value. You've got to think of two cases. Make sure you show the first case is the positive expression inside the parentheses. Thus I convert from absolute value to parentheses because I'm dealing with the parentheses. I'm evaluating them. Second case, you've got a negative 1 in front of it, and you're going to use the distributive property. Okay, so let's go down this half here since I'm over here. You get negative 2x minus 1 when you distribute the negative 1. Now add 1 to both sides, you get negative 2x greater than 8. Now look what happens here. Ran out a little bit of room. You are now dividing by negative 2. Okay, you've done this 100 times. What happens when you multiply or divide by a negative, class? Say it. Switch the inequality sign. Don't forget it. Now it's a less than. So x is less than negative 4. Okay, now look at these two. This was an OR case, and of course you get the union symbol here. And so now you're going to produce the gull wing, so you find negative 4. That's this case over. X is less than negative 4. You're going to the negative infinity. X is greater than 3 would be the right-hand side, and there's your graph. Okay, now, real quick, they will ask you for the set notation. Let me do this here real quick. You are going to go and do two parts of this. I need to fit this in here. You're going to go from negative infinity, and you're going to negative 4. Putting parentheses because you do not have the equal signs with it. Then you use the union symbol, and then you're going to go and do the right hand side of the gull ring. So you're going to put parentheses positive 3 because you're not including it, comma, you're going towards positive infinity. Okay, make sure you're comfortable with that because they will ask you that on MyMathLab. Okay, so here's our case number 3b. Same problem, except now it's the less than symbol. So you're going to put the word and you're going to remember it's the arch or the intersection. Think of the overlap. Okay, now we solve these solve both cases. Here's the positive case. Here's the negative. Let's go do the negative. Do the negative distributive. Negative 2x minus 1 less than 7. Add 1 to both sides. Divide by negative 2. Don't forget to do what? Switch the inequality sign, and now x is what? Greater than negative 4. Union that, intersect it with, when you solve this for x, you guys can do this fairly straightforward. X is less than 3. Okay, now when you graph both of these, you get the overlaps. X is greater than 3, x is less than 3 is going this way. x is greater than negative 4 is going this way. You need to find the overlap region, which is right in here. Okay, now for this case, when you write the notation, you're going negative 4 comma, that's your smallest value. That's the solution. It's not from negative infinity to positive infinity. It was the region that satisfied both the intersections. So you're going from negative 4 and you're going up to 3 and with the parentheses. Okay, hey, we've just done page 2. We got to move on to page 3, so I will sign off now and I'll catch you on page 3. Okay, bye.